Okay, we're going to do calculus rates of change. And you see this picture on the first slide is about rates of change that involve displacement, velocity, and acceleration. We're going to, and this will become a little bit clearer what's going on here as we go on. You remember the derivative is a rate of change. It's a change in y with the change in x. And there are many examples of rates of change, and you can get different questions in the exams. But one of the main ones is distance, speed, time, and acceleration. You remember probably this triangle from your science class too, that I think we do it in math sometimes too, that speed is distance over time, like kilometers per hour or meters per second. And distance is speed times time, and time is distance over speed. Okay, and now there's different types of distance versus time relationships. Here, we can see it's a horizontal line. The gradient is 0, so the speed or velocity would be 0 because there's no change in the position with time. But if you've got a change in distance over time, if there is a change, but it goes up in a constant way, then this would be a constant velocity or speed. But here, this last one here, the graph curves indicating that the speed changes over time. And if this is a function, if we found the derivative, we could find the rate of change at any point along here. That's what calculus is all about. Okay. There's some things that are a little bit confusing sometimes, is that S is the symbol for displacement, for distance actually. Not exactly, it's a change in position. And that's the tradition in physics and that they use S. V is for velocity. And velocity is actually speed with direction. If you take physics, you should know that. It's a vector quantity. And acceleration is a vector quantity. That's what makes sort of speed and velocity, that's the difference between them, but they're very closely related. They're both, there's still rates of change and in the same distance over time in a way. But there we go. And let's take a look at an example here. An object moves according to this distance equation. You see S of t means S stands for displacement. It's actually the distance that's changing. And according to this formula, and it's the distance that's covered in meters in time t in seconds. Determine the velocity and acceleration of the object at t equals 3. Well, the velocity, what we have to do, we know this is a parabola right here, and the derivative is the velocity, the rate of change. That's the velocity or speed. So all you do is you take the derivative. You go 2 times t, you get 2t minus 4. And then they said, what's happening at 3 seconds? So you put in 3 seconds. Well, it's going 2 meters per second. Hey, that's not too hard. What about the acceleration? Well, then we take this derivative and the acceleration, we take the second derivative. We take the derivative one more time. We take the derivative of the velocity, the second derivative of the displacement thing. And what do we get? The derivative of this is 2. So that means it's accelerating at 2 meters per second every second. 2 meters per second squared. That's how we write it in physics. So when the equation giving distance is derived, we get velocity. So the derivative of the displacement thing gives velocity. But the second derivative, or the derivative velocity, gives acceleration. And that's what that picture's about. If you've got displacement, you just take the derivative and you get velocity. And if you have velocity and you take the derivative, you get acceleration. Oh, I like that little, the little pictures there. They're pretty good. Okay, there you go.